quiz I gave you the other day. And I had to, the way it was set up was if you were to get one of those matching questions wrong, like it would prorate your question there. So it's out of 19 points. If you got one wrong, it should be 18 out of 19. You got two wrong, 17 out of 19, and so forth. But it turned out, and I think this is why you weren't seeing your scores right away. One, I had to go in the question that I asked at the end with just your preparation. I had to go in and score that 0 out of 0. Which, good job. It's the one you got right. But the first one with the 19, I had to go in and if you missed one of them, it said 0 out of 19. So I had to fix that for everybody. They should be visible now. If not, let me know and I'll see if I can work things out on my end. But I'm trying to get things kind of positioned with like my grade book. So I want to show you just real quick, just kind of how nasty my grade book looks. So I've got all of these things, and they're all kind of different groups of people and that kind of stuff, and I've got to figure out what assignments that need graded, go in and get them, pull them out from certain things. So it's kind of a nightmare right now getting grades, kind of situating, getting used to that stuff. So it's taking some time, but I will get on top of that this week, and those will be posted. So that last question on the quiz, I'm going to do, I think it's important for us to always, no matter what we do, whether it be educationally, whether it's sports, okay, a lot of you play game Friday night. What do you do Saturday morning? Wake up and go to and film, right? Go watch. You reflect, right? And that's what that's about. See what did I do right? What did I do wrong? Kind of like JV. So I got to see what I did right, what I did wrong. Maybe reflect about the approach that I took that week in preparation for that game, and then think, okay, what do I need to change so the outcome is better next time? We should do that same thing in the classroom. Okay, we take a test, we take a quiz, even do homework. You get a score and you think, okay, was that a good score for me? Did I like that score? And then think, okay, even if it's a good score, okay, if you got 100% on it, you don't just say, well, heck, all right, I don't have to do the reflection thing because I got what I wanted. Still reflect. I got 100%. What got me there? Because now there are behaviors there are going to copy and take over to the next assessment that I take. Okay. If I got a 30%, okay, what behaviors or lack of behaviors did I go through, procedures that I could fix that would maybe help with that, or what were the contributing factors that led to that maybe 30% or whatever. Does that kind of make sense? So that is purely for you to reflect and to put down on paper. Kind of, I think it resonates more if you can see that and you can actually be honest with yourself and answer those questions. So that we'll keep doing that. I don't know. The format might change a little bit, but you can expect something like that on every quiz or test that we take. We were finishing up now. We did talk about these two vocab words last Thursday, but I want to reiterate them again because they're so important. They are essentially the structure of every research problem that we're going to do is going to incorporate one of these things. This is kind of what we have to decide before we even start collecting data. Okay, and it goes hand in hand in what kind of data we're collecting and what judgments or arguments we're going to try to make. Okay, so we need to be able to identify and pay attention to the types of sampling techniques that are being used. Just an overall idea, random sampling is the idea that every person or every object in the population has an equal likely chance of being chosen for the sample. Okay, I think we talked about last week. If Lucas has 1/20th chance of being chosen for the population, or for the sample, but Peyton has a 1/4 chance of getting chosen from the population into the sample. That means that we kind of weight Peyton's responses more importantly than what we weight Lucas's. Does that make sense? Okay, or his data is now carries a higher weight and is more important, and that is a problem for us. Okay, so we want them both to have the same equally likely chance of occurring. So we don't have bias, we don't have skewed data, that kind of thing. Okay, there's several types of random sampling methods, and we talk about some of them have good aspects of them, and some have poor aspects. Okay, so talk about the ones here that are good quality sampling techniques that are really the ones that we want to kind of focus on, but there are still some things that we need to pay attention to, and even though they're good, there are things that could arise that we need to make sure we're aware of in regards to being biased. Does everybody understand what I mean by bias? Okay. So simple random sampling, a simple random sample is a set of n objects, so lowercase n. So that's, whenever we talk about in this class a sample, usually it's a lowercase letter that's going to attach to it, because a sample is usually smaller than or it is always smaller than the population, right? Okay. Capital N is the population. So we're taking n objects from capital N things, and each of those possible samples are equally likely to happen. Meaning, if I take a population of 100 people, and then I sample 10 out of there, every single possible sample of 10 out of that 100, okay? Every one of those samples is equally likely to occur. Does that make sense to everybody? Okay. That's a simple random sample. We talked about using a number generator to do that, a random number generator, random number table. I think there's a homework question, that 1112, that kind of walks you through the usage of a random number generator or random number table. That is, this is a nice, we hope for simple random sampling. We want to be able to use that, but sometimes we can use what we call stratified or cluster samples, okay, or even systematic sample that might be a little bit more useful or maybe more appropriate for the situation, okay. Stratified sample, okay, we have a population that inherently is divided into groups, subgroups, okay, kind of like the high school population. We have freshmen, sophomore, junior, seniors, right? Okay, we might have, think about the school population. Maybe we use clubs, okay, or athletics or something like that, and that is a group that kind of takes the population and automatically subdivides it, right? Okay. When they do data on end of course exams or ACTs and stuff like that, they group you gender-wise, they group you ethnicity-wise, they group you socioeconomic-wise. Does that kind of make sense? Okay. So those could be groupings that we could go with. Okay. But stratified means you divide the population into groups, and they're called strata. Okay. And then we choose, using the simple random sampling technique, a proportional number from each one of those. Okay. So let's say we have, let's say I want 40 people. Let's kind of write this down so that we can see a specific case and how we talk about this proportion idea. Let's say I have, let's just use the classes, because I think that's just an easy scenario that everybody kind of understands. So we got freshmen, we got sophomores, juniors, and seniors. Okay. So let's say we got 100 people in each one of those classes, and I want to create a random sample. Okay, a stratified random sample here. It's stratified because we've already got these groups. Okay, they're already predefined groups. Proportionally, because they're all the same, I want to take, let's say I want to create, from these 400 people, I want a 20 unit sample. Okay, so I'm going to take 5 out of here, 5 out of there, 5 out of there, 5 out of there. Does that make sense? Okay. Now let's say that when I create my sample here, that my freshman had 200 people in it. Everybody else was 100. Okay. Proportionally, because this is twice as many people, I better sample out of that group twice as many of what I sampled everywhere else. Does that make sense? Okay. So if this one is 150, okay, I better take 7 to 8 people out of that to keep the size proportional to everybody else. Does that kind of make sense to everyone? Okay. And that's the one thing that stratified is different with simple random, is because I'm now looking at these subgroups and then doing the simple random, the number generator or the number table with those, choosing out the people. But I need to make sure that I pick out a sample out of each class or strata that is proportionate to the overall population. Is that okay? And the reason we do that, if we go back up to what we talked about last week, is a key concept is that a sample should have the same characteristics as the population it is representing. Okay? So if I have, and let's just make this drastic, let's say I have 1,200 freshmen, 150 sophomores, 100 juniors, and 100 seniors, and I go 5, 5, 5, 5 out of each of those, is that group of 20 representative of my population? No, I've got 3/4 of my population or my sample coming from 350 people, where I've got 1/4 of my sample coming from 1,200 people, right? Okay, so this is definitely disproportionate. Therefore, this sample would not share the same characteristics as the population, because the population is going to be dominated by freshmen, right? So the idea is that population is going to have is dominant in freshman-like characteristics. Okay, so we would want to sample that. Does that make sense? Or make sure that shows up in our sample. Questions on that? Usually when we talk about stratas and using stratified sampling, they are already structurally created groups inside some type of system, okay, whether it be a school, population, maybe it's a workforce, okay, maybe, if we did, like a large high school or a large school district, something like that, maybe it's the science department versus the math department versus the English department, those types of things. Does that make sense? Those are already created structures in which people are inside of and operate within, okay? Cluster sample is very similar. Cluster sample is similar in the fact that you're going to break them up into groups, okay? You guys have all kind of done this where, so somebody like Lucas wasn't always picked last in gym. They would put you in a row and they count off 1, 2, 1, 2, 1, 2, right? 1's over here, 2's over there, right? Okay. We can do that with other. We don't have to stop at 2 and go. If you've ever done competitions in a team event or something like that, maybe you have 5 different groups or 6 different groups, and they go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and 1's over here, 2's over there, 3's over there, right? And you split up, okay? So that's creating these random groups, okay? Then what we do for our sample, instead of sampling out of each one of those groups, we just take that group as a whole, and that's our sample. That make sense? So it'd be the idea. Now we wouldn't do this because it wouldn't be representative of the high school population, but it'd be like taking freshmen, sophomore, juniors, and seniors, breaking them up, and then saying, okay, we're going to take the seniors, and the seniors is now our sample group. We don't go inside of each one and pick so many people out of each one. We just take the entire group, and that's our sample group. Does that make sense? Now, if we did that, would that be representative of the high school? No. Okay, seniors are going to have different characteristics than juniors and sophomores and freshmen, right? Same thing with this would probably make more sense maybe with the staff. The staff is broken up into departments, and they want to survey the staff about certain things that we do. Maybe they would say, okay, we're just going to survey the math teachers, or we're just going to survey the English teachers, because those are the clusters, and they're just going to ask each one of them. Those are the only people they're going to sample. Okay. Again, probably not representative. There's things that I do on a daily basis, and then I want and need that is different than what an English teacher wants and needs and does. Does that make sense? Okay. But there are situations where a cluster sample is a good idea. Okay. Systematic. This is probably one that we're most familiar with. I think the example that I used last week is if we have like a phone book, okay? Let's say I want to do a telephone survey, okay? And I'm just going to call 400 people, okay? I'm going to take the Allen County phone book, and I'm going to close my eyes. I'm going to flip through a page, and then I'm going to put my finger on that page, and that's going to be where I put my finger is going to be the first person I call, okay? Keep my eyes closed so that I don't have any bias, right? Okay? Call that person. They become sample object number one. Then I'm going to count so many people between. Okay, and these are all things that we would sit down and calculate and determine, okay, do I want 200 people between? Do I want 300 people? That kind of thing. Okay? So then I would count, say we want 300 people in between. So I would count from my first phone call, 300 more people, and then I make the second phone call. Does that make sense? And then I count 300 more people, and I make my third phone call. And I would do that all the way through until I get to the end of the phone book, okay, or I get my total number of samples. But if I get to the end of the phone book before I get all my samples, I would then just continue to count. It basically becomes cyclical, and I go back to the beginning and continue counting until I find that next person. Does that make sense? And then I obviously stop when I get my sample completed. Excuse me. So that's systematic sample, okay? And now you're going to hear and you're going to see, they'll call it stratified random sample, cluster random sample, systematic random sample, okay? I don't have those written in here, but these are all subgroups, subcategories of simple random sampling. Is that right? Sorry, not simple random, subgroups of random sampling, okay? Questions so far? Systematic is, like I said last week, P&G does this. We used an example in the first period of like Rydell. They make football helmets, okay? Or Schutt, or what is the kind of helmets we have? Is that what we have? Okay. So what they will do is they'll create, obviously these helmets, but then when they take one off the assembly line to make sure that it's meeting standards, their tests that they go through will actually destroy the helmet, right? So logistically, financially, it doesn't make sense to test every single helmet, or will destroy my entire product line, right? So they'll test every 100th, and they say, okay, now that we've done every 100th, this is our sample. Okay, maybe that sample becomes, 200 helmets in the duration of that line of production. And they say, okay, out of these 200 helmets, do they all meet the standards that we're looking for? Because if they do, then the argument is in the population of helmets, all the helmets we've made should meet those requirements. Okay, so that's systematic sampling. That's the idea that when we go to any grocery store, any retail store, just in general, you should be able to pick item 1, item 2, item 3, okay, from what you're trying to buy, whatever object it is or item you're trying to buy, and you don't have to sift through and weigh them out and say which one's better buy for me. Does that make sense? Okay. Questions on those? Those are our best types of sampling techniques. Okay. We're talking about some non-random sampling. Okay. They're still done. Okay. Not that we don't use these, and not that some research that is good research might still use these, but they open themselves up to a greater degree of bias than what the other techniques do. One's called convenient sampling, and convenient sampling is exactly what it sounds like. It's convenient. It's easy to do. Okay, results are readily accessible. Okay, if I wanted to survey you guys, let's say I want to survey the high school population, and I want to know what your thoughts are about the first 2 weeks of school and the new protocols that we're going through. Okay, and I asked you guys as you walk into class what your thoughts were, because it's convenient for me because I'm here. You guys are readily accessible as my students to answer my questions, right? Okay. Would you guys be a good representation of the entire population? Probably not, right? Okay. Because freshmen are going to feel a little bit different than seniors and juniors. Some of you are only here for a period or two. Okay, so you're only wearing your mask for a period or two. You only have to follow the walking in the hallways for a period or two. But if you're here like a freshman all 7 periods, maybe you have a different feeling towards those things than everybody else does, right? Does that make sense? So you guys would be convenient sample, but your results probably aren't representative of the entire population. Let's say that I wanted to survey the seniors, so the seniors are my population. Let's say juniors and seniors. Juniors and seniors are my population about their feelings towards the new protocols. Would you guys be, if I asked you as a convenience sample, would you be more representative of that population? Most of you are juniors and seniors, right? It's not all of you, okay? So there's situations where convenience sampling, as long as I'm able to determine whether my sample has same characteristics in my population, be a good tool to use, okay? But you can also see where it could be a very bad tool to use. So people that I'm easy to contact, easy to survey, whenever you see a scenario like that, it's a convenient sampling, okay? Another type of sampling that is essentially convenience, it's when we do mailings. So you guys know what the Nielsen ratings are? Okay, does anybody still have cable at home, like Spectrum and that kind of stuff? Okay, so I don't know if like the online streaming, if they're still Nielsen. I assume they are. They're still the same networks. But the Nielsen ratings are, they'll send out an envelope that asks you to record or report, I guess, what you prefer to watch on TV. Okay, and you hear all the time, like, you know, the NFL came out the other day and said the ratings were down or whatever. Okay, every time a new season starts on something, they say the ratings are up or ratings are down. Well, they get that information from the Nielsen ratings, which are mailers that they send out. Okay, now those are voluntary responses. Okay, so if it's voluntary, I'm not usually, and when I say I'm referring to like just human nature, all people. If you have a middle of the road response to something, I could take it or leave it, you usually don't respond to mailers or phone calls or something like that, okay? But if I get a mailer or a phone call from somebody doing a survey and I really, really, really like that thing that they're talking about, or I really, really, really dislike it, so I'm essentially biased in one direction, then I'm more likely to offer my opinion. Does that make sense? So surveys, like voluntary surveys, essentially, are very biased, okay? The Nielsen ratings, they actually give you $1. They mail you $1, and they hope that that incentive gets you to reply, okay? Sometimes they ask you to make a journal, a weekly journal of what you've watched and that kind of stuff. And if you do that, they give you $5, or they give you $5 and hope that you do that, okay? Well, those incentives are things that essentially kind of create some bias. You guys buy stuff off Amazon? All right, so I'm buying something off Amazon. Obviously, I've never had the product before. I just bought one of those. You guys see those like therapeutic massage guns? Yeah. Okay, like percussion guns. So I bought one of those a couple weeks ago, and like I've used one in the past before I bought it, and like I didn't know like reviews and that kind of stuff. So I start reviewing, right? Okay, I go through all these reviews looking for, you know, what's the best one out there, and what, you know, is it worth spending $500 on, or should I get the one that's $89? Okay, so you read the reviews on Amazon, but what is going on lately with Amazon reviews? You guys know? A lot of Amazon, well, one, just in general, if I'm going to review a product I'm going to get my product, and then I'm going to take time out of my day to get on my computer, log into my account, and then write a review on it. I probably either really, really, really like that product, or I really, really, really disliked it, right? That kind of makes sense? Like I said, a lot of people that are on the fence about things they can go either way. They usually don't write reviews, okay? So your reviews, just inherently because of that, are usually, because they're voluntary, they're usually biased one way or the other. So you see a lot of times you get like 5 stars, and then there's a lot of responses that are like 1 star, right? It's people really liked it or people really hated it. So it kind of gives you, should I buy it? Should I not buy it? You're still pretty much in the same position you were before you even started reading your reviews. That's at least the way I find myself most of the time. But Amazon reviews, I don't know when this all, like a lot of them, I'll give you a time frame, maybe last year, year before, finding out that they are paid reviews. So Amazon is paying people to review their products. You pay me to reviews, I'll tell you, you got a 6 stars out of 5 if you're gonna pay me, right? Like, so that generates some misleading data for people that are trying to use that to make a decision for themselves. So convenient sampling, being able to readily access or readily question or survey somebody because they're easy to contact, that's convenience. And with convenience, a lot of times becomes voluntary responses that are highly biased. Okay. So surveys conducted through mail-in or phone evaluations can lead to disastrous results. So usually individuals that complete mail-in surveys or agree to complete phone evaluations usually do so because they're really, really good products or really, really bad products. You ever call like a service like Spectrum? So I call Spectrum and tell them my service is down. At the end, like will you take a survey for us? Well, most people hang up unless they had a really, really bad experience or the person that they worked with was phenomenal, right? Most time then people that are just kind of they hang up and they don't fill out the survey. So those types of things are always things we got to think about and be concerned about when we're doing research. It says think political polls right now. Obviously, politics being a big issue. With political polls, if it's convenient sampling, let's say that I'm a Republican trying to figure out, what is the Republican Party's view on whatever, it's going to be easy for me, it's convenient for me to go to the Republican registration rolls and just pick people off that and call them, right? Does that make sense? So it's convenient. I have that information in my hand. Is it the best way? Probably not, okay, to get a valid conclusion. All right, so almost done here. When we talk about sampling, true sampling means we do the sampling with what we call replacement. You guys remember probability? And that's what all this stuff is about, okay? It's trying to deal eventually with probability, okay, and how we understand that concept. If I have 52 cards, playing cards, and I ask you what is the probability of picking out an ace and then putting it back in the deck and then picking out maybe another ace, okay? On that second choice, did the first choice matter at all? Because I replaced it, right? So when I replace it, the population, the 52 cards, stays the same. So the sample, which is basically the first choice and the second choice, they have equally likely chances of being chosen, okay? However, if I say, okay, I'm going to do this without replacement, so I ask you, what's the probability of picking an ace on your first draw? Pick it out, put it in your pocket, right? So that's 4 out of 52, right? 1/13. Keep it in my pocket. Now I ask you, what's the probability of picking another ace? 3 out of 51, right? The probability's changed, okay? That second choice is no longer equally likely to occur like the first one did, okay? So that changes things. That creates issues. So what we do with sampling out of populations is we want to do it with replacement, okay? But because of the mathematics, we understand that if our population is big enough and our sample is obviously not going to be as big as our population, with replacement or without replacement, the mathematics should be very similar. So let's say this. Let's say we have, let's say I'm surveying residents of Allen County. All right, and let's say that Brooklyn is chosen in my sample. Okay, she gets chosen. With replacement, this is the way we should do it. If I put her back in the population of Allen County, about 103,000 people, is it likely, and let's say I'm making a sample of 100 people, is it likely that she got chosen once, that she's going to get chosen second time? No. 100 out of 103,000, it was very slim chance that she was going to get chosen first, right? Okay. The likelihood of her getting chosen a second time is so minuscule that we can argue that it's not going to happen. So because of that, the idea is, okay, if she gets chosen one time as the first sample object, let's just keep her out, because now in finding the next person, I'm now dealing with 103,000 minus 1, and I'm going to pick the next person out of that. Does that make sense? And picking 1 out of 103,000 versus picking 1 out of 102,999 people, those probabilities are almost the same, right? Does that make sense? So just logistically, it's easier or simpler to do sampling without replacement, even though with replacement is best. Does that make sense? Okay. Because think about it, and it's because of numbers, the denominator essentially being big enough. Let's say our population out of here is, we got 15 people. Let's say I pick Lucas as the first person in the sample. Now everybody else to be chosen second has a 1 out of 14, right? Okay. So the further along you get in the list of sample objects, the better and better everybody's probability gets for being chosen. Does that make sense? Okay. But if our population is big enough, that's not really a big deal. Okay. That's kind of what this is talking about. Sampling error, this is huge. You guys do error in like margin of error and that kind of stuff in like labs, right, in science class? This is really the same idea, okay? When you do error in a science class, you have theoretical solution of what should be happening, right? Okay? And then you go through the experiment and you actually conduct the experiment and you get your data, you read your data, you interpret it, and you get something that doesn't really maybe 100% match what was expected, okay? But they're similar, hopefully, if you've done the experiment correctly. And you go through a little bit of a calculation to see that percent error, right? You guys do that? Peyton, you do that? Yeah? Okay. So sampling error is the same thing. We want to know, how close does my statistic, my sample statistic, model or represent my population parameter, okay? So there's a difference between those two things. Does that make sense? There's always going to be a difference, okay? So what I want you guys to do, I go into Schoology. We'll just do a quick kind of simulation of this. I mess around with it first period. We'll see how it goes with you guys. Let's go to where we were at. Schoology. All right, so there's, first of all, I want you to go to, when you click on the Schoology, it's going to just take you to here. Go to the one that says age calculator. Okay, just a link there. Sometimes just kind of working with this and seeing it on my side of things, with these links, sometimes it's going to take you to a blank page. Sometimes it's embedded. If it takes you to a blank page and you want to get to the actual site that I've got you going to, you can click right here. This will be a clickable link, and that will actually take you to the website outside of Schoology. Does that make sense? Okay. Is anybody else that's showing up embedded this morning? No, this wasn't here. This is new. But all I want you to do here, once you're in this calculator, just type in or put in your birth date in this first option, and then leave the today's date alone, and just calculate. It'll give you some information here about how old you are in certain pieces of units. Or am I? Yay. So, getting pretty close to my birthday, so you guys might want to put that down on your calendar. Presents, that kind of stuff. But I want you guys to, let's just take your days, how old you are, okay? And I want you then, so just keep track of that number. Then I want you to go to the other link that was on Schoology, and it's going to take you to a Google Sheets. All right, and I've got your names in there. And all I want you to do is next to your name when you're in this Google Sheet is I want you to type in that second column, that B column, I just want you to type in how many days old you are.
I'm gonna be younger than that.
It obviously allows us to collect data like this from everybody quickly, right? Okay, so instead of me sitting here and asking every one of you what your age was or whatever, but we can now see what the average is, okay, the average age, okay? And I want to do this for the population. So the population is all of us, right? Okay, so the nice thing here, we can go equals and just type in the word average, and then I can just select these. Okay, I'm going to delete Riley since she's not here, and just want to make sure that it doesn't add that as a 0 for the average. Okay, so our average number of days is 6,958. Okay, that is our parameter. Does that make sense? Because that is a statistic, or I want to phrase it as a quantity attached to the population or representative of the population. Okay, let's take a sample, and I'm just going to say let's just choose five people. Okay, now we should do this systematically or using a random numbers table or something like that, but just for time's sake, let's just take take that one, we'll take that one, take that one, take that one, and we'll take that one. And we get that. Okay? So that is the statistic. Okay? If we look at those, are they different? Yeah. Okay? Now, here's the thing. Was my sample representative of the population? Who did I include in that sample that maybe isn't? Yeah, I'm a little bit different than the rest of the population, right? So that then skews those numbers, right? Okay. So let's take me out. Let's take me out. So the difference in those would be the sampling error. Okay. So if I take me out and let's put that one in, look at that number. Is that number a little bit more aligned with the population parameter? Yeah. Okay. So the sample statistic, if our sample is representative of the population, our sample statistic should model our population. Not the same. There's still error there, but it's less now, right? Okay. We'll pick up with this tomorrow.